Welcome to the video lesson for section 9.6, polar coordinates. We're going to go over a couple conversion formulas to go from polar to rectangular and then from rectangular to polar, as well as discuss what a polar coordinate actually is. Let's get started. The polar coordinate system is a system similar to the Cartesian plane with the x and y axis, except for this system has the central point at the origin. It has a ray extending from the pole, which we're going to call the polar axis, similar to your x-axis. And then it has a directed distance from your point O to your point P, and an angle that's going to rotate from the polar axis to your point. So again, this is similar to the XY plane, except for we have a point and then we have an angle of rotation instead of an X and a Y value. Here we can see a diagram discussing the polar coordinate system. Again, for our origin, we have the point O. The polar axis always extends out to our right, and then we're going to be rotating from our polar axis to our point. And then for your coordinates, you're going to have the distance to your point, which is r, and you're going to have the angle of rotation from the polar axis, which is going to be theta. For some examples of our polar coordinate system, let's go ahead and plot some points. Our first point is going to be 1, pi over 2. That 1 is going to tell us how far we're going out from our pole or our central point, so we're going to go out 1. And then our pi over 2 is going to tell us how much we're going to rotate. So I'm going to go out 1 and then rotate to be at pi over 2. And I'm going to go ahead and take my point, again go out 1, and rotate to be at pi over 2. For my next point, we have the point 3 and then 5 pi over 3. So I'm going to go ahead and take a point. We're going to go out 3, and then we're going to rotate to 5 pi over 3. And we have our point approximately there. For our second point, we have 2 and 5 pi over 4. So again, starting at our pole, we're going to go out 2, and then we're going to rotate 5 pi over 4. Put our point. And then for our last example, we have 1 and then negative 4 pi over 3. So this time, we're going to go out 1, but we're going to rotate clockwise because it's negative. And we get our answer right around there. For our next example, we're going to go ahead and find 2 additional points for the point negative 1, 3 over 2. So to begin with, we're going to go ahead and graph that. Because it's a negative 1, we're going to start by going to the left. So we're going to go left 1. Then we're going to rotate 3 pi over 2. And we have our point. What we now need to do is write down 2 different ways to get to that point. So notice, again, we started off by going left and rotating 3 pi over 2. We could go to the right 1 and rotate positive pi over 2 and get at the same point. So we have 1 additional point. We also could have gone to the left and rotated clockwise a negative 3 pi over 2 to end up at the same place. There are several different things you could have done. Essentially, all you want to do is be able to end up at that same location, either by going left and rotating or by going right and rotating.